Here's some more examples of sublimation and deposition. Well, not just a visual picture. Right here, this solid block of dry ice, this is frozen solid carbon dioxide. It will never enter the liquid state. It will skip directly over the liquid state and go into a gas. And that's what you see here through the fog, is just the carbon dioxide being released. The reverse of that is deposition. Deposition is when you have a gas, and once again it skips that liquid state and goes directly to a solid. An example of that would be like water vapor in the atmosphere, and as temperatures decrease, as it gets very cold out, it will never actually go into like a wet snow. It will go into like a frost. And here's what you see here on the fence. You see that frozen solid gas on the fence, and that is frost. Okay, that is deposition. If I look here, this kind of gives an overview of water. This is the heating curve for water. Let me just kind of explain this. Down here at the bottom, okay, this is the point where we have a solid chunk of ice. Okay, as this purple line goes up, as temperatures are increasing, okay, you're going to reach a point at 0 degrees, this is Celsius, where both a solid and a liquid are present, and that's where this line flattens out. A solid and a liquid are present because we are melting. Okay, think of a piece of ice. If you leave that ice out, okay, it's going to eventually reach a melting point. You're still going to see that solid piece of ice, but you're also going to see a little puddle of liquid there as well. As temperature increases within this range right here, we're always going to have a liquid. Okay, some substance of water or whatever substance we're studying. And as that temperature climbs, increases, as energy is added, you will reach a boiling point. At that boiling point, once again, we have two state changes that are occurring at once. You still see a liquid, but you also see a gas. Think about when you're boiling pasta, water for pasta or for whatever. You see the water vapor that's coming out, but the liquid is still there. It's not completely evaporated. So the liquid is still there, but you can see that gas, and that is that boiling point. Now eventually, that energy and temperatures are going to continue to climb, and we will have our fourth state of matter, and this is just an example of it, plasma. Plasma is the fourth state of matter. Some examples of plasma that happen here on Earth are lightning, fire. If I think of welders, people that weld things together, weld metal, they have to wear those special masks. That flame that they produce to weld things together is actually plasma. Some examples in the universe, it's actually the most common state of matter in the universe. Over 99% of our universe contains matter that is made from plasma. The stars, the sun, which is a star, a lot of nebulas and things that occur in the universe are made of plasma. Plasma is a superheated gas. So take this chart, and it's way up here, plasma. Okay, it's a superheated gas. It has lost all of its electrons due to these really, really hot temperatures, and as we increase temperature, the pressure also increased. Okay, now here's a couple terms that if you can relate this to plasma, that would be good enough for me. When a gas gains electrons, it is called ionization. Okay, so as this temperature increases, gas is going to gain electrons. Gas is going to gain electrons. That's called ionization. Where we take a plasma that's happening up here and we want to change it into a gas, that is where we have, when a plasma loses electrons, it's called deionization, and therefore it forms a gas. Okay, so we're talking about those different state changes from a plasma to a gas and from a gas to a plasma.